It needs to be connected, because there's really no value unless this thing is connected. It has to have a very small form factor, has to fit on our body. And more importantly, think about this. We all talk about the amount of data we're transferring over this internet today and the security of it. But imagine when these devices are with us 24/7. The amount of data and information and personal content that will be exchanged. Security becomes even more important. So I have an announcement today that I didn't read in any of the pre-press. So we were able to keep it quiet. We're announcing today the Quark family of silicon, Intel's smallest SoC ever. This part is 1/5, roughly, the size of our Atom microprocessor, and approximately 1/10 the power. It is fully synthesizable with an open architecture and open ecosystem. It is designed for the Internet of Things. This is just an example of the silicon innovation that's going on inside of Intel. But again, that's not enough. Because if you're really going to do this, you have to understand the devices that you're going into. So Intel has already been starting work on reference designs. We have reference designs for industrial Internet of Things. These are boards designed to be on the edges of the network, out on the extreme environments, to connect machines back to the internet. These are reference designs ready to go to our developer community and actually out into industry already. Come with software, they will come with that open architecture and that open ecosystem. Because this device is fully synthesizable, if companies have their own intellectual property they'd like to put into the silicon, we can support that. This is truly designed for this open environment. But that's not enough. Because I said this is not only about industrial, I said it's about wearables. It's about people. And so yes, we have been working on wearables. No questions. We have wearables. These are reference designs. This one's a little bit more, I'll call it lab-oriented. But we've looked at form factors, actually. This is a form factor we've been playing with. The idea is not necessarily for Intel to bring these to market, but to come up with devices that partners could use to develop their own products in this open ecosystem. They can, again, write their own software, develop their own applications, and drive this product into the market themselves. But what we needed to do was build things so we really knew what did the customer need, what do the developers need, and so that we could bring these products to market with applications all ready to go. You can only do that if you have the reference designs. Okay. So what does this mean for the future? The landscape of computing has never been bigger. I've tried to show you each segment as we walk through. I've tried to show you some real innovation that's going on. We've introduced several new products. We've talked about Bay Trail and its ability to get us into lower priced entry points and really innovative 2-in-1 designs. We talked about 14 nanometer Broadwell, and actually showing you functioning
What it's doing is it's taking a constant reading and transmitting reports wirelessly to a service. This is actually a real-time EKG, blood monitor cuff, and other vitals just from a wristband. I mean, it's not very, it's pretty big and unattractive, but what this replaces is an entire, it's on this table on the end, bunch of equipment that you would have to have in a medical clinic. And it gives you real-time results to the doctor. Through the magic of what Intel does in the future, this patch, this silicon-based patch, will replace that wristwatch that I just had on. This will be directly on your skin. This patch will perform all of the same functions that that wearable does today. This is from a company called MC10, and it's a prototype right now. So why is this important? Thanks. That little patch thing is like a Band-Aid. You just peel it off and stick it on. And so why is that important? Because it's a constant data stream that your doctor can see that if something's wrong, it's immediate, it's up to date, and it's accurate. And it allows us to move into the most exciting phase of healthcare that I think is in this frontier for us. And that is moving into customized care. Care that's actually tailored to the things that are going on in your body. There are a tremendous number of other devices and other applications, injectables, ingestibles, that we've looked at. I didn't have time for all of them today, but all based on the fundamental, foundational building block of this industry, which is the silicon transistor.